Hello. So this is our project on CS 683 checkpoint 1. Our project title is improving IPCP with irregular access support using ISB. Team members are Arif Ali and Shomik Dotto. We are team Gandiva. Let's start from the problem statement itself. So we know there are prefetchers which actually used to prefetch memory access requests so that we can mitigate the latency. This instruction pointer classifier based prefetcher, in short called IPCP, actually is a integration of multiple prefetchers where the prefetchers integrated in it actually handles the regular access patterns. By regular access patterns I mean that it can track based upon strides. Strides is difference between two simultaneous access memory accesses. But there are different workloads which also has irregular memory access patterns. For example, graph processing. So, and I can give you an example of irregular access pattern which involves temporal locality is below. Here we can see these memory accesses. We are not bothered about the strides here, and basically there is no consecutive or no correlation between strides at least. But here we can see this access pattern is again repeating here. So these type of access patterns comes under irregular access patterns, which tracking which is till now cannot be done with this IPCP prefetcher. So moving next, what are the prior works done in this field? As I discussed, this IPCP thing is proposed in ISCA 20 titled with bouquet of instruction pointers, which basically involves and integrates 4 prefetchers. First is constant stride, which tracks the strides between first order strides between two consecutive addresses. Next is the complex stride, which tracks second order strides between consecutive addresses. Third is global stream, which actually tracks frequent accesses inside a region of memory. And the fourth is the most common next line prefetcher. The other work in this area is that ISB, irregular stream buffer, which is proposed in Micro 2013. It actually proposes how to track and prefetch temporals irregular access pattern, example temporal stream. This stream, as I showed in this previous slide, can be tracked by this prefetcher. Here is the GHB, it is the global historic buffer, is maintained by most of the prefetchers to store all the memory accesses, and ISB implements this data structure which actually stores physical addresses in terms of linear structural addresses. The main crux here is it doesn't check or store the strides, what is the difference between the addresses. It doesn't track those, but it actually stores the addresses till now visited or shown, and based upon the correlated consecutive addresses, it prefetches the next addresses. Moving next, so what is the goal of our project is we want to get the best of these two prefetchers, and we want to integrate this temporal prefetcher called ISB into that bouquet of prefetchers that is called IPCP. So we can get both the spatial axis pattern tracking and also with the temporal axis pattern. So for that, as we can see from this figure, all these 4 prefetchers are already there in bucket. Now we want to add our extra, that new the component. This is ISB prefetcher, just in between this global stream and next line prefetcher. So all these are operated by their predefined priorities, and also which confidence level they are in. And just before going to the next line, we will use our ISB prefetcher to also get the best out of the temporal stream tracking. And now, so next, moving towards the work done so far, Arif.
So for the work done so far, first we took the already existing artifacts of IPCP and ISB and integrated them in ChampSim simulator, and then we took downloaded the gap benchmarks and a subset of the spec CPU benchmarks to evaluate these prefetchers. And also after this separate evaluation, we also tried the initial integration of both the prefetchers logic into a single prefetcher, and then we did some testing. So these are the initial test results. So both the IPCP and ISB prefetchers have reported their performance on the spec CPU benchmark. So we have tried to replicate that. And so here basically ISB is proposed at the L2 level and IPCP is proposed in both level, but here we are using the IPCP at L1 and the ISB at L2, and our combined prefetcher is running in L1. So we can see the different trays having different performance, and but if you see the geomean bars, we can say that basically our performance, our combined prefetcher shows like almost the same, like practically the same performance as IPCP, and but is not able to beat them, but also there is no performance degradation. So next we tried test results with gap. So this is a new benchmark for both prefetchers. Others have not done this before. So here this is a strange result for us, because ISB is for irregular workloads, but here ISB itself is not able to beat IPCP alone in the benchmarks. You can see the various bars that they are all always ISB is always lower than IPCP, and also because of that our combined performance is also not good here, and also mostly performs like the average of the two, like 1.12 in the geomean and 1.07 for our things. So we are planning to further tune and adjust the parameters for this gap benchmarks. Also we are planning to meet with professor and discuss what will be the plan with this benchmark going ahead. So these are our plans for checkpoint 2. We have noticed that in the ISB prefetcher, it doesn't use the confidence counter to influence the prefetch decision. Like it, even if a stream has a low confidence, it prefetches that stream. So we have to use that to influence, and also the degree is fixed for the ISB prefetcher and doesn't change based on accuracy. In IPCP we have seen that it actually modifies the degree based on accuracy seen after some like 256 prefetch fields. So we are planning to integrate the same logic for ISB also. And also since we are making it as a single prefetcher, we can reuse the IPCP IP table with ISB to store the various IPs and the last seen addresses which the ISB needs. Also there are some ISB parameters like the look ahead distance, the current buffer size for ISB, and also the length of the stream that is being currently tracked, the length of the temporal stream. We can adjust these parameters and see what is happening. And also we need a refination of the classification logic for the irregular access class. Yeah, that will be all. So this is the GitHub link of our project up to checkpoint 1.